In this video, we are going to look at the routing protocol RIP. RIP is one of many routing protocols not widely in use, not widely in use with Cisco-only networks. Integrating with some other networks, particularly in SMB, small, medium businesses, you'll probably see that. So, now RIP being a routing protocol deals with layer 3, so our routers are going to have to handle this, but our switches and PCs don't. We see on the screen 3 routers, a couple switches, a couple PCs. And just to get familiar with it, we'll take a look at the configuration, the network addresses, and kind of see what has access to what at this point in time before RIP is configured. So if we look at our first router, if we look at gig 00, we have an address of 192.168.0.1. That's this interface right here, which is connecting over to this router. We look at 01, which is coming down to our switch, and that's got an address of 10.1. Now if we look at our PC has an address of 192.168.10.10. It's on the same network as our router, so we should be able to ping that without a problem. Alright, we can ping it, no problem. So let's go take a look back at our second router. We look at our second router, gig 00 is 0.2. So remember, this is 0.1, this one's 0.2. They're on the same network. But to hop on the other side of this router, interface 01, we're at 1.1. So it's through here that we are changing our network addresses. We're changing the network. And that's where we're getting to layer 3. So let's go back over our PC. And we said this was 10.1 and this is 0.1. So can we ping 0.1? Well, let's try. The answer is no. And it can be for one of 2 reasons right now. First of all, maybe we don't have a default gateway set up on this PC, so it doesn't know where to go when it's not on its own network. Or maybe it's because once it does hit the default gateway doesn't know how to get to the other side of the network. Okay, so let's take a look at the PC configuration. We can do it the easy way, go into global settings. Here we go. Here's where we can define the gateway. So we defined it as 10.1, which again is going here. Let's go back to our desktop, command prompt, ping it again. So there, we can ping it. We can ping the 0.1 because this PC is going to its default gateway, which is this router. And this router knows that 10.1's over here, it's attached. 0.1 is sitting over here. Well, can I ping 0.2? Why can't I ping 0.2? Well, let's take a look at the router and maybe we can figure out why. So if we go into command line and do a show IP route, we can see here that in the route statement that is on that router, we can see over here on the left, we see these little the codes, and up here's the index for the codes. C means connected. So we know we're directly connected to 0.0. We also know we're directly connected to 10.0. And right here with the L, meaning the local address, that is the address of the interface itself, the 10.1 and the 0.1. Now, we can ping, or we should be able to ping, the 192.168.0.2. Let's give that a try. So we can ping it from our router, but from our PC, we can't. So let's go back to our router. Okay, so why can we ping from our router, but not from our PC? Well, if we look at this logically, the PC knows to go to its default gateway. So it hits the default gateway, and then to get to the 0.1, it goes to the router. And that router here, it knows it has route statements for that .10 network. So it knows to go right back through here. However, when it goes across this router and across the wire to the second router, this router does not have a route statement. Let's take a look at it. See, this router doesn't have a route statement for the .10 network. It has one for the .0 and the .1. So thus, as this packet came across, once it jumped over here to this router, this router didn't know what to do with it, so it dropped the packet. It gives a destination unknown. Where from this router, we're able to ping the other router because they're both on the same network, and it didn't have to cross over 10. They both know about the .0 network. All right. So let's go on and start configuring RIP so that all these routers know about each other. They know about each other's networks. So right here's the .0 network, right here's the .1 network, right here's the .2 network. So let's go into our first router, and to configure it, we go conf D as normal, and we issue the command router rip. Now, as you can see, there's nothing after that. You just hit enter. And now if you put a question mark, you can get some other items in here. Now, we've just enabled RIP, but now we got to tell the system what networks we want to advertise. So you typically want to advertise the networks. You typically want to advertise networks that are attached. So we had the 0 network and the 10.0 network. Now, at this point, this will be sending out RIP advertisements over both of these interfaces. Now, if we come over to this router and do the same thing, but instead of the 10 network, it's the 1 network. So this one has the 0 and the 1, where this one had the 10 and the 0. Now if we do a show IP route, if you remember a while ago, it was a little bit shorter than this, and we only had these C's and these L's. Now we have some R's. So this one has learned through RIP, and if we go up here, the R stands for RIP. We've learned that the .1 network is accessible via this interface, the 192.168.0.2. Come back over to this router. And here we can see that the .10 network is accessible. So now if we go to our PC and we reissue our ping command, we will get replies. Not only will we get replies from this side, we'll get replies from this side. So that was 1.1. Now we're getting replies from here. So similar to previously, if we try to ping this, which is the 1.2, we will get failures. We will get failures until this router learns about the networks and routes to them via RIP coming from this one. So let's go here. Let's go in, add. So now if we look, we see it's learned about the .0 network and about the .10 network. So going back over to our PC, we should be able to ping the 1.2. Now as a final thing on here, let's say we now have RIP enabled on all three of these. Now the advantage is when you start adding new networks, all you have to do on this device, we're going to add a new network to this device, is start advertising that network, and these guys will automatically pick it up. So let's go over here into the config. We'll go to gig 02, and we'll make that one 192.168.20.1. Turn the interface on. Go out of the interface config and we'll go back into router RIP and we'll say network 192.168.20.0. Now when we come over to our first router and we show the routes, we may have to wait a minute. So while we're waiting, we'll come over here and connect some devices. We'll give this an IP of 192.168.20.10. Go in here and give it a default gateway. And we'll ping 10.10, the other PC on the other side of the network. And let's see what happens. There we go. After one request timeout, we get a reply. So that's telling us now we have connectivity from here all the way through to here. We didn't have to touch this router. We didn't have to touch this router. Didn't have to touch the switch. Didn't have to touch the PC. Through RIP, these other routers learned where the .20 network was because this one advertised it. So if we go over here and we reissue our show IP route, we'll see there's our new route statement right there. 192.168.20.0 is accessible via 192.168.0.2. So notice that it just points to the next step. This is it, 0.2. This one, in turn, will point to here, which tells it to get to that .20 network, we got to get to this router then this router knows where to go. So hopefully that gives you some ideas on how to do some basic configuration of RIP. We'll get into some more complex features in RIP, but just wanted to get you started with that.